Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular paper is Edexcel 2021, paper 2, higher tier. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1a, write down the inequality shown on this number line. Okay, well you can see we've got an open circle at -1, okay, and then an arrow pointing off to the right, which means that our value of x is going to be bigger than -1, isn't it? So x is greater than -1. Now notice this has got an open circle at this end. That means it is strictly greater and not greater than or equal to. So it can't actually be equal to -1. So it's x is strictly greater than -1. For B, it says on the number line below, show the inequality -3 is less than or equal to y, which is less than 4. So again, we're going to have two circles on our number line, one at -3 and one at 4. And then these are going to be joined up with a straight line because y is going to be between those two endpoints. Okay, and finally we need to think about whether or not the endpoints themselves are included in the range. With -3, y is greater than or equal to -3. That means it can be -3. So in order to show that, we shade this one in, we fill it in. Okay, so it's kind of like a solid circle on this end, because -3 is part of the region that we want. Now on the other end, we've got that y is strictly less than 4, so it can't actually be equal to 4. So again, just with the same as part A, we show that one as an open circle. Okay, so that's that one. Question 2a, find the highest common factor HCF of 60 and 84. Okay, now there are different ways of doing highest common factor. Probably the most simple to explain is the exhaustive search method. And that's where you find all the factors of both your numbers. So like all the factor pairs of 60, like 1 and 60, 2 and 30, and so on. Okay, that's one way of doing it. But when you've got large numbers like this, I actually think it's probably easier to use prime factor decomposition, or use product of prime factors, another way of saying it. So in order to do that, you need a calculator, a Casio one preferably, because that's got the feature on it. And then you type into it 60 equals, you need to press the equal button for it to work, and then shift, and then this fact key here. And this will tell you what the number is as a product of its prime factors. I think it's easy, it will give it to you in index form. I think it's easier just to expand it to find HCFs though. Okay, so that's 2 times 2 times 3 times 5. And then 84 equals shift fact. That's 2 times 2 times 3 times 7. Okay, So then the HCF is going to be made up of all the factors that are common to both. So I've got a 2 in both, a 2 in both, and a 3 in both. I've got a 5 in one and a 7 in the other, so they're not common. So we take all the ones that are in both, like the 2, and the 3, multiply it together. 2 times 2 is 4, times 3 is 12, and that would be the HCF. So the HCF of those two numbers is 12. Okay. Find the lowest common multiple of 24 and 40. Now, similarly, there is a method for doing this just by listing out all the multiples. So you can do 24, 48, and so on, and just kind of list them all out and see if you get one on both lists. So you go up from 40 as well, 40 and 80, and so on. So a kind of similar sort of exhaustive search. Alternatively, again, you can use product of prime factors here as well. So again, if I put 24 and 40 and I type 24 equals shift fact into my calculator, that gives me 2 cubed times 3. 2 times 2 times 2 times 3. And the other one, 40 equals shift fact. That's 2 cubed times 5. 2 times 2 times 2 times 5. And then, so as before, the ones that are in both kind of form the HCF. Now the LCM ones you can do in one of two ways. Probably the easiest one to explain is to just draw a Venn diagram. So this is for 24's prime factors, and this is for 40's. Drop in the numbers that are in both in the middle, 2, 2, and 2, and put the factors that are not in both on either side. So the 3 is going to go here and the 5 is going to go here. So once you've got all your numbers in the Venn diagram like that, then the LCM is just going to be all of those numbers multiplied together. So 3 times 2 times 2 times 2 times 5. So what's that then? 3 times 2 times 2 times 2 times 5. That comes out to be 120. Okay? So that's the way to do it with prime factor decomposition. Like I say, you could also just carry on with this list and get to 120 on both lists. That is a perfectly acceptable way of solving it. Which one is quicker or which one is best? It's hard to tell really. Sometimes it takes quite a while to find an LCM just by listing them all out. It could be there for a while before you find one on both lists. So I would say as the numbers get big, and particularly if they're large and close together, then doing it with prime factors can be a lot quicker. Question 3. Sam drives his car on a journey. Here is the travel graph for the first 15 minutes of his journey. Okay, we've got a little stumpy graph here. Work out Sam's speed in kilometers per hour for the first 15 minutes of his journey. Now, speed can be found by looking at the gradient of a distance time graph. Okay, because speed is the rate of change of distance with respect to time. So if I can find the gradient of that line, I should know what the speed is. Okay, so just going to kind of get a ruler out, just draw a little triangle here. Okay, and then we're going to look at change in y divided by change in x. Okay, so change in y, the difference between the y coordinates is going from 20 down to 0. So that's a distance of 20, isn't it? And then the change in x, I've got from 10 o'clock to 10:15. Okay, now presumably this is in kilometers per hour. We need to do it in. Yes, so I'm not going to write, rather than writing 15 minutes, I'm going to convert that into a quarter of an hour then. So a quarter of an hour. Okay, that's the same thing as 15 minutes, isn't it? So then the speed then is going to be change in y, which is 20, divided by change in x, which is a quarter in hours, a quarter of an hour. But if you think about it, dividing by a quarter is the same thing using keep change flip as times in by 4, which is going to be 80 then, isn't it? 80 what? 80 kilometers per hour. Part B says at 10:15, Sam stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometers per hour. on the grid, complete the travel graph for Sam's journey. Okay, so he's stopping for 10 minutes. So if he's stopping for 10 minutes, he's not moving anywhere, is he? Okay, so for this section then, it's going to be flat for 10 minutes. So from 10:15 through to 10:25 then, he isn't going anywhere. So I'm just going to draw a kind of flat line between there and there. Okay, and then maybe I'll do it in green so it stands out a little bit more. Let's just try that again. Does that stand out a bit more? Hope so. So yeah, from 10:15 to 10:25 he's standing still. And then for 20 minutes after that, which will take me to 10:45 then, he is going to be traveling at 75 kilometers per hour. Okay, so how steep is that going to be then? It's a bit hard to use the gradient of 75 here because the graph doesn't go up that long and we haven't got hours on there anyway. I suppose we could scale the gradient down a little bit, but I think probably the easiest way of doing it is just do a quick distance, speed, time calculation, DST. So using the DST triangle, let's just work out how much distance he can travel in 20 minutes. Okay, so distance is what we're trying to find. Speed we know is 75 kilometers per hour, and time is 20 minutes, which is 1/3 of an hour, isn't it? Okay, so then distance, cover up what I want to, so distance is what I'm trying to find, so cover up D, so that tells me what to do with the other two. It's speed times time. So distance equals speed times time, which is 75 times 1/3, or in other words, 75 divided by 3, isn't it? So that is 25 kilometers then. Okay, so I know then in 20 minutes he's going to go 25 kilometers. So I can come along to 10:45, which is 20 minutes later, and I'm just going to go up 25 kilometers up my scale. So I'm currently at 20. So if I add on 25, that's going to take me up to 45. So I'm going to have a point then here, which is at 10:45 at a height of 45. And I'm just going to then join that up with a straight line. Okay, so then that's my completed travel graph then.
Question 4. Complete the table of values for y equals x squared minus 2x plus 2. Okay, now this is a calculated paper, so this is very much a job for the calculator, and in particular the table mode. So if you press the mode button on your calculator and go into table mode, which is option 3, you should get a f of x equal appear on the screen. Now f of x is equal to is the same thing as y equals to. So what we need to do is to tap this equation into the calculator after that. So now notice that we need to start with an x squared, and there's a little x in red above one of the brackets. Press the alpha key, I can access that little x there. So x squared minus 2, alpha key again to get the x again, plus 2. Okay, so you can see x squared minus 2x plus 2 on my screen, the same as what's on the paper. Press equals. Now if you've got the latest Casio, it's going to ask you for g of x here. We don't need a second function. This table has the ability to do 2 functions at once, but you only need 1. So just press equals again to skip over that. Now the start value, that's going to be our lowest value of x here. So we need to start at -2. So -2. End value, well, that's going to be up at the other end. We're going up to 4, aren't we? So our end value is 4. Step, what we're going up in here. Now if you have a look at the x values, they are going up in ones, aren't they? Add 1, add 1, add 1. We're going up in ones. That's the step, so we're stepping up in ones. Okay, now if I press equals again, it's going to create a table for me, and you can see I've got x values and y values here. So when x is -2, you can see on the table here I've got y is equal to 10, or f of x is equal to 10. Okay, and now that matches up with my value that I've got down here, isn't it? So I've already got that one down there, so that matches. Next I've got -1, that goes with 5. So I'm going to write my 5 here on the table. Next I've got 0 goes with 2. Again, that's already on the table there. I've already got 2, so that gives me a bit of confidence. Going down a bit more, I've got 1 and 1, so let's write the 1 in. Then I've got 2 and 2, so let's write that in. And then 3 and 5, again, I've already got that one on my table, so it's all matching up, so it's all good. And then finally 4 and then 10. Okay? Now you could just take these values of x and sub them into the function one after the other to generate the numbers, but the table function does it really, really quick, and you can just get all the values out really easily. So that's a really straightforward, easy 2 marks if you use the table function. Right, on to part B. On the grid, draw the graph of y equals x squared minus 2x plus 2 for values of x between -2 and 4. Now notice this is the same function as we had in part A. So basically we're just plotting the same points. Now each pair of values that we've got here in the table is going to be a coordinate that we need to draw on our graph. Now I've gone ahead and plotted the points and joined them up with a nice smooth line. When you're drawing your curve, it's important to make sure you skewer each of the points. So you want to go through each of the coordinates you marked, and make sure you're just using one line. Some people kind of feather and they kind of have a couple of goes at drawing a curve and end up having multiple lines on their graph. That is not what you want. Okay. Also, this is a quadratic curve, so you're expecting it to be the shape of a parabola, aren't you, with a line of symmetry going down the middle. That is a classic quadratic curve parabola. It's called parabola. So that is what you're expecting to see. So that is the shape that I've got, so I'm pretty confident I've done it right. Now, if you've got a point that's lying off of that shape, then you've probably made a mistake on that point, so you just want to go away and check that again.
Finally, part C says use your graph to find estimates of the solutions of the equation x squared minus 2x plus 2 is equal to 4. Now note again, this is the same equation as parts A and B, so we're not having to change it in any way. We just want to know where this graph is equal to 4. Now the easiest way of doing this is just to draw a line at y is equal to 4 and see where it crosses our existing line. Okay, so I'm just going to draw a line at y is equal to 4, across like that, and you can see that then my lines intersect here and here. Okay, so reading down to the y-axis from those points. Okay, so I think this is quite good method. Let's try and get an accurate reading. So you could see the one on the left is at negative. It's kind of between -7 and -8. So I'm going to say it's -7.5. So x equals -0.75 is 1. And on the other end, I think that one is at 2.7. So that is my other one, or x equals 2.7. So they're my two solutions then. Now you're going to be given a little bit of leeway in this because plotting points is always a little bit inaccurate. So expect like a half square either way on the correct answer, but I'm pretty happy with those. Question 5, here's a right angle triangle and it's got sides 8 and 10 millimeters on the two shorter sides. The shaded shape below is made up of two of these triangles. So it's got one sitting on top of the other. Work out the perimeter of the shaded shape. Give your answer correct to 3 significant figures. Okay. Right, now we know most of these lengths, don't we? So we've got the perimeter, and it's made up of this side here, 8, plus this side here, 8, plus the hypotenuse of this triangle that we don't currently know, plus this little weird wobbly bit here, and then 10. Okay, so we know 3 out of the 5 sides at the moment. Now that long side there, that hypotenuse, I can find, can't I, using Pythagoras theorem. C squared equals a squared plus b squared, where C is the longest side of your right angled triangle and A and B are the other two sides. Okay, so I've got A squared, which is 8 squared, plus B squared, 10 squared. What's that then? 8 squared is 64, 10 squared is 100. So then C is going to be the root of 164. Okay, now I could write out what the root of 164 is now, but I'm going to have to use it in another calculation. So I'm going to try and just maintain accuracy and leave it like that at the moment, because I don't think root 164 comes out to be a nice answer. Okay, so I'm just going to leave it as root 164 for now. Okay, and then let's see if we can work out this last little bit. So now we've got this side, we know this side we know is root 164. So the last thing we need to do is this little teeny tiny bit here. Okay, now if you think about it, that length there is the difference between the hypotenuse of our triangle, which we know is root 164, and this side of it, the side which is 10. So in other words, that little bit there is root 164 minus 10. Okay, so then the perimeter of our shape is going to be all those sides added up. Now we know what they all are. So I've got 8 plus root 164 plus root 164 minus 10 plus 10. Okay, right, so what we've got there, I'm just going to cancel those off straight away. Minus 10, 10 cancel. I've got 2 lots of 8, so that makes 16, and I've got 2 lots of root 164, so 2 root 164. Okay, now at this point then I'm going to reach for the calculator and tap it in. 16 plus 2 root 164. That comes out to be 41.61. How do I need to round it off? To 3 significant figures. So to 3 significant figures then, that is going to be 41.6 then, isn't it? To 3 significant figures. Okay, so 41.6 millimeters to 3 significant figures. Question 6, ABC is a right angled triangle. Work out the length of BC, given your answer to 1 decimal place. Okay, so here we've got sides of a triangle and an angle, and we want to find the length of another side. I think this is a job for trigonometry, isn't it? And for right angle triangles, we're going to be using our 3 trigonometric ratios, which we can remember with the mnemonic SOHCAHTOA. Okay, so in order to work out which one of our 3 ratios we need to use, the easiest thing to do is just to label up the 3 sides of our triangle. Okay, so I have, well, the longest side is the one I usually go for first, so that's our hypotenuse there. Now this side here that's marked is adjacent to the angle, isn't it? It joins onto the angle, so this is the adjacent side, and then BC is on the opposite side of the triangle to the angle, so this is the opposite. Okay, now in this triangle I have been given the adjacent, and I've been asked to find the length BC, which is the opposite. Okay, so I wasn't given a letter, so I think I'm going to give it a letter. I'm going to call it X. Okay, that's the one I want to find. Okay, so I've been given the opposite. So I want the opposite. I've been given the adjacent. So which ratio has to do with the opposite and the adjacent and not the hypotenuse? Well, it can't be sine because that's got the hypotenuse in it, and it can't be cos because that's got the hypotenuse in it. It has to be TOA, okay, which stands for tan theta equals opposite over adjacent. So let's write down the full equation for tan theta. Okay, and then once we got that down, it's just a matter of then plugging the numbers in from the diagram into the correct spaces in the formula. So tan theta, theta is the angle, isn't it? So theta here is going to be 56. So tan 56. Opposite is the side we want to find. I called that x. That's something I introduced. Okay, but it's all right. You can use letters if you want to. And then the adjacent then is the side I was given over there. It's the 12. Okay, so sub that in as well. Okay, then next what we're going to do is going to rearrange this. I'm going to cross multiply that 12. Multiplying both sides by 12 has the effect of shifting that divide by 12 on one side to become a times by 12 on the other. So I'm going to get 12 tan 56 is equal to x. At this point, I'm going to reach for the calculator. Just double check it's got a little d at the top, otherwise you're going to get the answer wrong. 12 tan 56. That comes out of my calculator to be 17.79. Now I need to round this to one decimal place, so that 79 is going to round up to 17.8, isn't it? So 17.8 centimeters to 1 dp. Okay. In part B, we're given triangle PQR, and this time we've been given an angle which we don't know, and we've been given two other sides, and we need to work out the size of the angle marked x, and again we need to give our answer correct to one decimal place. Now this is still a right angle triangle question, so it's still going to have to do with our three trigonometric ratios, SOHCAHTOA. TOA. Okay, now this time I've been given, I want to find the angle x, but I've been given the angle that joins onto x, which is the adjacent. I've been given the longest side of the triangle, which is the hypotenuse. I've not been given, nor do I want to find the opposite. Okay, so that means I'm not really interested in anything to do with the opposite. So sine is out and tan is out. I think I want the cosine here. Okay, that's got to do with the adjacent and the hypotenuse, isn't it? Okay, so again, writing out the full equation for cos theta is equal to adjacent divided by hypotenuse. Okay, now again I'm going to scan through the diagram and pick out the things that I need to put into my formula. So first up, the angle. Now the angle's down here. This time I don't know the angle, so I'm just going to say cos x. I'm going to switch to the letter that they've actually given me in the question. The adjacent, that is this side down here. That's the adjacent, isn't it? That's 15. Okay, and then the hypotenuse is over here. Look, that's 18. So cos x equals 15 over 18. Now we've got the cosine of x and we want x. So we have to kind of do the opposite of finding the cosine to cos x. Now the opposite of finding a cosine is the inverse cosine. So doing that to both sides will give me x on the left, and on the right I'm going to get cos to the minus 1 of 15 over x. Okay, and that is exactly what I need to type into the calculator in order to find x then, isn't it? Okay, so I'm going to get the cos to the minus 1 or the inverse cosine button. I need to press shift first before pressing cos, and you can see I then get cos to the minus 1 showing. I want to type in 15 over 18. I'm just going to use the fraction key. So 15 fraction key 18. Okay, I think it's good practice to close the brackets before you press equals. Mostly it doesn't matter, but sometimes it does, so I recommend just put them in. And then that comes out to be 33.55 and change, which to one decimal place I'm going to round up to 33.6. This is an angle, isn't it? So it's going to be degrees. 33.6 degrees to 1 dp. Question 7. Liquid A has density of 1.8 grams per cubic centimeter. Liquid B has density of 1.2 grams per cubic centimeter. 80 cubic centimeters of liquid A is mixed with 40 cubic centimeters of liquid B to make 120 cubic centimeters of liquid C. Work out the density of liquid C. Okay, so Density, let's just remind ourselves what density is. Density is mass of an object divided by its volume. Okay, so the more dense something is, the more mass it has in the same amount of volume. Okay, so if we want to work out the density of liquid C, we will need to know the mass of liquid C and the volume of liquid C. Okay, now do we know either of those things? Well, the volume we know the volume of liquid C, it's here. We took 80 centimeters, cubic centimeters of liquid A, and we added 40 cubic centimeters to liquid B. So when you add 80 and 40 together, it's going to give you 120. It's not going to miraculously grow to a bigger volume, I don't think, not unless it kind of reacts or does something weird. So presumably it's going to give you 120, and in fact it tells you it does. So we know what the volume is. What we need to know is the mass, okay? Now, in order to work out the mass, we're going to have to go away and we're going to have to find out the mass from liquid A and liquid B first, because we don't currently know them. If I can find the mass of liquid A and liquid B, I can add it together, and I should be able to then find the mass of liquid C, because we're going to add the two masses together. Okay, so let's do that then. So let's find liquid A. We want to find the mass. Now, if density equals mass over volume, then rearranging that formula, then mass is going to be equal to density multiplied by volume. Okay, rearranging that formula. I'm just kind of moving that up there, aren't I? Okay, cross multiplying the volume to get mass equals density times volume. So for liquid A, the density is 1.8 grams per cubic centimeter, and the volume is 80 cubic centimeters. The units match because I've got cubic centimeters there and cubic centimeters there, so that's all good. So multiplying those together, I should be able to get the mass of my liquid A. So 1.8 times 80, that comes out to be 144, and that's going to be 144 grams, isn't it? Equals 144 grams. Okay, so I've got the mass of liquid A. Now I'm going to have to do the same thing again for liquid B. So for liquid B, again, mass is still equal to density times by volume. But now my density of liquid B is 1.2, and the volume of liquid B is 40. So 1.2 times 40, that comes out to be 48. So it's 48 grams. So for liquid C, its mass is going to be equal to those two things added together, then, isn't it? 144 plus 48, which is, what's that, 192. So its mass is 192 grams. Its volume is 80 plus 40, that's 120 cubic centimeters. So then the density is going to be its mass divided by its volume. Okay? So mass divided by volume, 192 divided by 120, that comes out to be 8/5, 1.6. Okay? And 1.6 is reassuringly between our two densities of our given liquid, isn't it? It's a kind of like, it's averaging them out a little bit, isn't it? So it's 1.6. I was expecting it to be between the two of them. If it wasn't, I was going to be worried, but it is, so I'm not. Question 8. The group frequency table gives information about the time in minutes taken by 50 people to solve a puzzle. So 5 took between 0 and 10, 8 took between 10 and 20, 12 took between 20 and 30, 15 took between 30 and 40, 7 took between 40 and 50, and 3 took between 50 and 60. Brian was asked to draw a cumulative frequency table for this information. This is the table that Brian drew. Write one thing that is wrong with the cumulative frequency table. Now, as far as I can see, he's kind of added them up correctly. The first value in your cumulative frequency table should be 5. The next one you're going to get by adding 5 and 8 together, which is 13. The next one you're going to get by adding on the 12, so 13 plus 12 is 25. Next you're going to get by adding that 15 on, which is 40, then add on another 7, that's 47, and you add on another 3, that's 50. So all of these values in the cumulative frequency are correct, there's no problem there. Okay. Now the one thing I think is incorrect is this bit here, how he's labelled it. Okay, now you'll notice that this is labelled the same way as the frequency table, and that's not what you do. So actually this first group should be labelled t is less than or equal to 10, okay, because it includes all the values less than or equal to 10. This next one should be t is less than 20, okay, so it includes all the values that's less than 20. In other words, it includes you know, both of these in here, okay, and so on. It should be t is less than or equal to 30. Okay, so it doesn't have this left hand limit on this side. That's not going to be there, because if it was there, then it should be the same as the frequency table above. Okay, so that isn't quite right. So I'm going to say that Brian has incorrectly labeled the time groups it should read t is less than or equal to 10, t is equal to less than or equal to 20, t is less than or equal to 30, etc. Okay, I think that's good enough. Question 9. The box plot shows information about the length of time in minutes some people waited to see a doctor at a hospital on Monday. Work out the interquartile range of the information in the box plot. Okay, so in this box plot, this down here is Q1, the lower quartile, and this up here is Q3, that's the upper quartile. Okay, so to work out the interquartile range, what you're going to be doing is you're going to be subtracting Q1 from Q3. So it's Q3 minus Q1 basically. Okay, so that's what you need. In other words, it's the width of the box. Okay, that is what you're calculating. Okay, so the interquartile range is the same thing as the width of that box there. Okay, so can you see Q3 there? Just reading down, look. It's there. So this scale is going from 160 to 200 in 10 jumps. So it's spanning 40 units in 10 jumps. That means each little jump must be +4 then, isn't it? So it is 160, 164, 168, 172, 176, 180, 184, 188. Okay, so the Q3 score is 188. In the other direction, Q1, again, counting up. Where's Q1? Q1 is, it's actually halfway between those blocks, isn't it? I see that as. So that is 40, 44, 48, and halfway between 48 and 52. So I'm going to say that's 50. Okay, so that's 50. Okay, so the interquartile range is going to be 188, take away 50, so that is 138. Okay. Becky says 50% of the people waited for at least 2 hours. Is Becky correct? Explain why. 50% of the people waited for at least 2 hours. Okay, so 50% is where the median lies. Okay, remember the lower quartile lies 25 of the way through your data. The upper quartile is 75% of the way through your data. The median lies 50% through your data. Okay, so that little stripe in the middle of the box is at the median value, and so the median value here is 120. In other words, it is 2 hours. So I'm going to say the median is 2 hours. Okay, so what does it mean if the median is 2 hours? It means that that middle person waited 2 hours. Now, everybody to the right of the median waited more than 2 hours. Everyone to the left of the median waited 2 hours or less. Okay, so I think she's right, because if the median person is at 50%, that means 50% of the people are to the right of that, and that means 50% must have waited for at least 2 hours. So the median is at 2 hours, so she's correct. So she is correct, as 50% of people waited the median time or longer. Okay, so 50% of the people waited the median time or longer. Okay, so I think that's my answer. Yep, she's right. For part C, we've got an additional data table here. So the table gives information about the length of time in minutes some people waited to see the doctor at the same hospital on Tuesday. Okay, so we've got the shortest time, the lowest quartile, the median, the upper quartile, and the longest time. Becky was asked to compare the distribution of the lengths of times people waited on Monday with the distribution of the lengths of times people waited on Tuesday. She wrote that people had to wait longer on Tuesday than on Monday. Give one reason why Becky may be wrong. Well, I think the first thing I'm going to say is the median, isn't it? The median is 100 here. So on average, the people on Tuesday then waited 100 minutes, whereas on Monday, on average, the people waited 120 minutes. So it seems to me that on average, people actually waited less time on Tuesday than on Monday. So I'm going to say the median for Tuesday is 100 minutes compared to a median of 120 minutes on Monday, which may indicate that people on average waited longer on Monday. Okay, so give one reason why she might be wrong. The median for Tuesday is 100 minutes compared to a median of 120 minutes on Monday, which may indicate that people on average waited longer on Monday. And that is kind of contradicting her hypothesis there that people wait longer on Tuesday, isn't it? Okay. Question 10. Louise invests X pounds in better investments for 3 years. Sadiq invests X pounds in County Bank for 3 years. At the end of the 3 years, the value of Louise's investment is £344,605. Work out the value of Sadiq's investment at the end of 3 years. Okay, so this is quite a long problem. It's going to have a number of different steps, isn't it? So first off, we know how much Louise had at the end of her 3 years. Okay, now she invested in better investments, which is this one over here. Okay, so that's the one that she used. So what we're going to have to do is going to use that information to work backwards to find what this X value is. Okay, now once we know the X value there, we know that's the same as the X value that Sadiq invested. He invested his in County Bank for 3 years, so then we can then use this information over here to work out how much he had at the end of the 3 years. Does that make sense? Okay, I hope so, because that's what we're going to do. Right, so let's start with Louise. Louise, okay. So we know that her final amount that she had was 344,605. Okay, now I'm going to use a technique called putting my thumb on it, FOM. Okay, I've got a little triangle here, FOM. I like to use these for pretty much all percentage questions, and compound interest is just a subset of percentage questions. So FOM, final original multiplier, and then the mnemonic I use is to put your thumb on it as a way of trying to remembering the letters F, O, and M that go in the triangle. Okay, so the final is the amount that Louise had at the end of the time. The original, that is what we're trying to find, isn't it? We want to know what she had to start with. That's our X value that we want to find. Now the multiplier, you can see that the multiplier is 2.5% per annum for better investments. So when you're doing a percentage increase, you always start with 100% and then you add on the percentage that you're adding on, which is 2.5 in this case. That gives us 102.5%, which as a multiplier is 1.025. Okay, so once we know that, then we can cover up the thing that we want. We would like to know the original. Okay, and then we're going to put in the other things then. So original equals final divided by multiplier. So original equals final divided by multiplier. Now, but when we're doing compound interest, we have to then raise that multiplier to the number of years that we're applying. Okay, so whatever number of times that we're applying that multiplier for. Okay, so it's a slight variation on the FOM formula, but just have to remember when you're doing compound interest to raise your multiplier to the number of years that that you're talking about. Okay, so final is 344,605. Multiplier is 1.025, and we're going to be raising that to the number of years, which is 3. Okay, time for the calculator. So 344,605. I'm going to use the fraction key because I definitely want everything to be on the bottom. 1.025 to the power of 3. Okay, so that looks like what I've written down. So I'm going to press equals. Oh, that comes out to be a nice answer. That is quite reassuring. So that comes out to be 320,000. Okay. I don't think that's a coincidence. I think we're on the right track. Otherwise, it wouldn't come out so nicely. Okay, so that's Louise. Now we know Louise, we're going to spin around and we're going to go back the other way because we know that Sadiq invested the same amount. So we know that Sadiq must have started with the same amount. So I'm just going to draw my triangle again. F, O, M, and I'm going to work out what F, O, and M is now for Sadiq. Now this time we don't know the final. That's the one we're trying to find, isn't it? Okay, and we know the original was the same value that Louise started with. So he must have started with 320,000 as well. Now this time the compound interest of 2% per annum for the first 2 years, and then 3.5% annum for each extra year. Oh no, this is going to be a pain. So we're going to have to do it twice, aren't we? Oh, really, examiner. Okay, so let's do 2% first. So 100% plus 2% is 102%, which is 1.02 as a multiplier. Okay, so then the final, then cover up the thing you want. Final, it tells you what to do with the other two, original times multiplier. So for Sadiq, final equals original times multiplier, which is 320,000 times 1.02 squared. Okay. Now I could work that out and do this all again for the next one, but I might just do this. That's multiplier 1. Multiplier 2 is at 3.5% for the third year. So that's 100% plus 3.5%. That's 103.5%, which as a multiplier is 1.035. I'm just going to multiply through by that additional multiplier, I think, for the third year rather than doing it all and doing it all again. So if you think about it, I'm taking the 320,000, I'm multiplying by the 2%, the 2%, and then the 3.5%. Okay, so that should work out to be my final amount. Okay. Now, if you don't follow that, then you could just as have easily have done a third stage of this, and you do the 2 first, and then you can do the extra one on the end of it. But essentially, you are doing more work, and I'm a bit lazy, and I like to do a little work. Okay, so 320,000 times 1.02 squared times by 1.035. What does that come out to be? That comes out to be £344,580 and 48 pence. 344,580.48. So not bad. He made £24,000 by virtue of having lots of pounds to start with. Question 11. Here is a sketch of the line L. The point P at -6, 0 and Q at 0, 3 are points on the line L, and you can see they've been marked on the diagram. The point R is such that PQR is a straight line. PQR is a straight line. So in other words, R is further along the line L. Okay. The point R is such that PQR is a straight line, and P to Q to QR, PQ to QR is in the ratio of 2 to 3. So for every 2 units we've got here, we've got 3 units up here then, haven't we? Okay. Find the coordinates of R. Okay. So I think all we need to do here really is to work out how far it is in this direction and how far it is in this direction. And then what we need to do is scale that up, don't we? And then we can use that to work out how far it is from here and how far it is to here, because they should be related by that ratio, shouldn't they? Okay, so how far is it in the direction of x, and how far is it in the direction of y from P to Q? So if you have a look at the x coordinate of P, we're down here, look at -6. And then if you go to the origin, then you're going to be going 6 units to the right to get to the origin. So that's 6. And then to go from the origin 0, 0 up to Q, which is 0, 3, we are going 3 units up. Okay? Now the ratio of this to this, we were told, was in the ratio of 2 to 3. So if we take those distances and we divide them by 2 and we times them by 3, we should get the corresponding distances for the next bit from Q up to R. So if I take 6 and I divide it by 2, I'm going to get 3. And if I times it by 3, I'm going to get 9. Okay, so if you think about it in the other way, if I've got the ratio of 2 to 3, if I've got 6, that is 3 times bigger than that one. So times that by 3, I'm going to get 9. Okay, they're going to be in the same ratio. So that must be 9 there. Okay, now if I've got 3 on this side and I want to know what it is on that side, that's a little bit trickier. Well, basically it's half that one though, isn't it? It's going to be 4.5 by just taking that and dividing it by 2, I suppose. We can do that, divide by 2. So then I'm going to have, for 3 there, I'm going to have 4.5 here, which is kind of 3 halves of the previous one, isn't it? Okay, so how does that help us? Can we use that to find the coordinates then? I want to find the coordinates of R. So if I'm at Q and I'm at the coordinates 0, 3, and I go 9 units to the right, then my R coordinate then is going to be 0 plus 9. It's going to be at 9 there. Okay. Then for the Y coordinate, if I'm already at 3 here in the direction of Y and I go up another 4.5, that's going to take me 4.5 units above 3. That's going to take me up to 7.5. So my Y coordinate for R is going to be 7.5. So the coordinates of R are 9, 7.5. Right, then part B says find the equation of the line that is perpendicular to L and passes through Q. Perpendicular to L and passes through Q. So the line that is perpendicular to L passing through Q is going to look something like this. Okay, now, and that's at right angle, isn't it? Now to find the equation of this line, every equation of a straight line is of the form y equals mx plus c, isn't it? Now I already know the y-intercept of this line because it's, well, basically it's here, isn't it? Okay, I know where it passes through the y-axis. It passes through it y is equal to 3. So I know c already. C is equal to 3. Now do I know the gradient? No. But I could find it, couldn't I? Because I could use the information I know about L to find the gradient of L. And then I could use that to find the gradient of the perpendicular line, couldn't I? So let's find the gradient of L. Gradient of L, which I'm going to call M1, that is going to be change in y divided by change in x. Okay? Now I'm just going to take the first triangle because the numbers are easier. So if you remember, it was 3 units up and 6 units along from P to Q. So the change in y, 3, divided by the change in x, 6, gives me a gradient of a half. Okay? So then the gradient of my new line, so the gradient of the perpendicular line, which I'm going to call M2. Now the gradient of a perpendicular line is the negative reciprocal of the other line. So if I know M1 is a half, then I can flip that over. So half becomes 2 over 1, or just 2, and then I change the sign so it becomes minus 2. So my perpendicular line has a gradient of negative 2. I already knew the y-intercept was 3, so now I know everything I need to know for this line. If the gradient is 2 and the intercept is 3, then I can plug my gradient in there and I can plug my intercept in there, and then I've got the equation of the line. So therefore, equation of line is y equals m minus 2x plus c, 3. Y equals minus 2x plus 3. Question 12, expand and simplify x minus 2 times 3x plus 2 times 2x plus 3. Okay, so we've got a triple bracket here. This is going to be fun. So x minus 2 times 3x plus 2 times 2x plus 3. Okay, so what I'm going to do first is I'm going to work out multiplying these two brackets together first using FOIL. First, outside, inside, last, or 2 eyebrows, a nose, and a mouth. I'm just going to leave this x minus 2 alone for now at the start. We'll come back to that a bit later on. Okay, so let's just do FOIL on this next, the last two brackets. Okay, so I've got 3x times 2x. That's going to give me 6x squared. I've got 3x times 3. That's going to give me 9x. I've got 2 times 2x. That's going to give me 4x. And I've got 2 times 3, so that is going to give me 6. Okay, so just tidying up those two middle terms, both in x. That's going to give me 6x squared plus 13x plus 6. Okay, right, now I need to do the same thing again. I need to multiply everything in the first bracket with everything in the last bracket. Okay, I'm going to start off by multiplying the x with everything. So the x times that one, the x times that one, the x times that one. Okay, so what does that give me? So x times 6x squared, that is going to give me 6x cubed, isn't it? X times 13x, that's going to give me 13x squared. And then x times 6, that is going to give me 6x. Okay. Right, and then what I need to do is do the same thing again, but for the negative 2. So negative 2 times 6x squared, negative 2 times 13x, and the negative 2 times 6. Okay? Right, so negative 2 times 6x squared is equal to minus 12x squared. So just as a top tip, rather than writing that on the end here and making a very long kind of thingy expression over here. I mean, I could just write it over here, couldn't I? It would be perfectly acceptable. But just as a top kind of technique, rather than writing it there, when we go on to do our second bracket, I like to write it here underneath. So if you imagine you've got a columns of cubic numbers, square numbers, x numbers, and so on, I kind of write them one underneath each other. So because minus 2 times 6x squared gives me negative 6x squared, a squared term, I'm going to write it under our existing squared term here, and I'll show you why in a minute. So I'm going to write it there, 12x squared. I'm going to do the same thing with the next one. Negative 2x times 13x, that's going to give me negative 26x. I'm going to write it under that one. And then finally, negative 2 times 6 is negative 12, okay? And then just the reason I'm doing that is that it just makes collecting like terms a whole lot easier. Because if you can see, I can kind of then just add up these columns. So I add up that column, add up that column, add up that column, add up that column. Okay, so I'm kind of adding, because I rank them like according to their type, it makes it very easy to collect them together at the end. So there's 6x cubed. I've got 13x squared minus 12x, that's plus x squared. I've got 6x minus 26x, so that's minus 20x. And I've got minus 12, okay? So yeah, just a bit of a top tip about how to organize your maths. Hopefully that was helpful. We're done, let's move on. Question 13, in a school there are 16 teachers and 220 students. Of these students, 120 are girls, 100 are boys. One teacher, one girl, and one boy are going to be chosen to represent the school. Work out the number of different ways there are to choose one teacher, one girl, and one boy. Okay, so let's just summarize that then. So we've got teachers, girls, boys. We've got 16 teachers. We've got how many girls? 120 girls. And how many boys? 100 boys. And altogether, does it matter that there are 220? I don't really think so. Right, so one teacher, one girl, one boy are going to be chosen to represent the school. Work out the number of different ways there are to choose one teacher, one girl, and one boy. So basically, you're just going to have to multiply all those together. Okay, so the number of different ways, it's going to be a huge number. You won't believe how many ways there are. So how many ways is that then? So 16 times 120 times 100. There are 192,000 ways of picking this team of 3. Okay, quite a lot of ways. Okay, that's it. Question 14. A, B, C, D are 4 points on a circle. SBT is a tangent to the circle. Angle ABD is 20 degrees. The size of angle BAD compared to the size of angle BCD is in the ratio of 3 to 1. Find the size of angle SBA. Give a reason for each stage of your working. Okay, now quite a lot of information written below the diagram. I do like to just go through and double check that everything in the text is on the diagram. So let's just go through that line by line. A, B, C, D are 4 points on the circle. A, B, C, D, there they are. SBT is a tangent to the circle. SBD is T is a tangent to the circle. Yes, it is. Angle ABD is 20 degrees. Angle ABD is 20 degrees. That's there, yes. The size of angle BAD to the size of angle BCD is in the ratio of 3 to 1. So where's BAD? BAD, so that angle there compared to BCD is in the ratio of 3 to 1. So that isn't on there, is it? Okay, let's just get rid of this. So let's just do that a bit more neatly. So comparing this one to this one, so they're in the ratio of 3 to 1. So BAD is 3 for every 1 you've got in BCD. So I'm going to just show that as 3x and x, that one up there is 3 times bigger than the other one. Okay, and we want to find the size of angle SBA. SBA is that angle there. Okay, right, so quite a lot going on this diagram. We've got cyclic quadrilaterals, we've got this alternate segment theorem, and we've got a little bit of algebra that we've introduced because of the ratio. So we've got quite a lot happening that we're going to have to kind of sort our way through. Right, I think what I'm going to do is I'm going to start with the cyclic quadrilateral ABCD, because I looked at it for a little bit and I was trying to work out an in to this question, how I can get started. Okay, because normally it doesn't, I wouldn't massively over focus on the thing that I want to find. I want to find this one over here, but it will come. Okay, like with these harder problems, you've got lots of things you need to sort out. So I just think, well, what can I find straight away, and then see what I can find from that, and then hopefully I'll make my way around to the thing I actually want to find. Okay, so I'm going to start with the cyclic quadrilateral because I know a fact about cyclic quadrilaterals. I know that in a cyclic quadrilateral, then opposite angles sum to 180 degrees. Okay, now the reason I picked on that one is because I know that these two in relation to each other, these are opposite angles in a cyclic quadrilateral, and because I know their size relative to each other, that is enough to work them out, isn't it? Because I can say that, so in ABCD, angle DAB plus angle BCD equals 180. Okay, in other words, 3x plus x is 180. In other words, 4x is 180. So x then is going to be 180 divided by 4. That's 45 degrees. Okay, so once I got that, now I know that this one down here is 45, and this one over here is 3 lots of 45, which is, what's that, 135. Okay, so therefore DAB is 135 degrees and BCD equals 45 degrees. Okay, so we're making progress. So we now those. So now, if you have a look in triangle ABD, angles in a triangle sum to 180 degrees, don't they? Okay. So I know A is 135, B is 20. So A plus B plus D is going to be 180. So I know that A is 135, B is 20, plus D is 180. So 135 plus 20, that takes me up to 155. So take that away from 180, that's going to leave me with 25 degrees for D then, isn't it? Okay, so angle D there then is 25 degrees. So that one there is 25. Okay, now I think I'm pretty much done here then, because the last thing I want to look at is the alternate segment theorem. So I've got a tangent here, SBT, and I've got a chord drawn at the point of contact going in this direction. And the alternate segment theorem says that the angle between the tangent and the chord is equal to the angle subtended in the alternate segment, which is this one here. It's the 25 degrees. Okay, using alternate segment theorem, then I'm going to say then that angle SBA equals angle ADB equals 25 degrees. Okay, in other words, angle SBA is 25 degrees. 25 degrees. Okay, so that was quite a bit of work to do that. So I used the cyclic quadrilateral first to find those two angles. Once I had those, I could use angle in a triangle to find D, and once I had D, I could find the alternate segment theorem to find SBA. Okay, it worked out in the end. Good, let's move. Question 15. Here is a triangle ABC. Find the length of BC. Give your answer correct to 3 significant figures. Okay, so we've got a non-right angle triangle here. We know some angles and sides, and we want to find the other side. Now I'm just going to quickly label these other sides in terms of opposite the angle. So the side opposite angle A, we're going to call side A. The side opposite angle B is going to be called side B, and the side opposite angle C is going to be side C. Okay, let's just get rid of those again to free up my my diagram a bit. Okay, so they're the 3 sides. Now, when we've got non-right angle triangles, we have 2 trigonometric rules at our disposal. We have got the sine rule and we have got the cosine rule. So normally with these sorts of questions, the first thing you're going to have to do is decide if one or other of those applies to the situation you've got. Now, I think of the sine rule as about opposite pairs. Okay, opposite pairs mean that you need to have 2 pairs of opposite sides and angles in order to apply the sine rule. So either that you've got a side and an opposite angle, and you've got the side opposite the angle you want to find, or the angle opposite the side you want to find. Now that is not the case here, because I've got 1 pair here. I know the angle at A and I want side A, so that's good. But I've got no other angle to pair with the other 2 sides that I know. So I don't have an angle over here that I know to side with that side C, and I don't have an angle opposite B. So I'm not going to be able to apply the sine rule here. Okay, so it's not the sine rule, so hopefully it's going to be about the cosine rule then. Now the thing about the cosine rule I try to remember is the cosine rule is about 3 sides. Okay, so either you've been given all 3 sides and you want an angle, or you've been given 2 sides and an angle and you want the 3rd side. Now that is what we've got going on here, isn't it? I've got 2 sides and the included angle, and I want the 3rd side. Okay, so this is a clear case of using the cosine rule. Okay, so the cosine rule says c squared equals a squared plus b squared minus 2ab cos c. Okay, or you can then reformulate that to any side that you want, or you should be able to. Now I want side A, so I'm going to start with a squared. It starts off a bit like the Pythagoras theorem, a squared equals b squared plus c squared, but then we take away 2 lots of those 2 letters again, whatever those squared ones next to there we write again, and then cos, and then the angle which is opposite the side that you want to find. So I would need to be subbing into a squared equals b squared plus c squared minus 2bc cos a. Okay, so I know b is over here, it's 8, so 8 squared plus, I know c, it's over here, look, it's 11. 11 squared minus 2, lots of 8, lots of 11 again, cos the angle, and I know the angle as well. Angle A is up here, look, it's 72. So it's cos 72. Okay, so that's it. And then I tend to do as much of this as I can, because there's quite a lot of things to type into the calculator. It's quite easy to get it wrong. So I tend to do the maths that I can do in my head quickly. Okay, so I know that 8 squared is 64. I know 11 squared is 121. I know that 2 times 8 times 11, what's that? 16 times 11. Well, 10 16 is 160, and another 16 is 176. So it's 176 cos 72. And by doing the kind of easy maths in my head, it just makes it easier to type the whole thing into the calculator, I think. Okay. Yeah, so I might even go and add 64 and 121 together and type that in, but I'm going to be lazy now. 64 plus 121 minus 176 cos 72, I believe that comes out to be 130.6. Okay. Now remember, that's a squared we found there, so if we want a, we're going to have to square root that, aren't we? Okay, so root answer that comes out to be 11.4 to 3 significant figures. Okay. Now, just try and imagine your length in the triangle. Does it look sensible? If I wrote 11.4 here, does it look like it fits? I think it does. It looks like it's going to be the longest side of this this triangle, and it is slightly longer than the other one. Is the longest one of the three. I think it looks right. You know, if it was like 8, 11 and 130, then I know immediately I've made a mistake and probably I've just forgotten to square root. So just as a top tip, just imagine your answer in your original diagram. Does it look right? Does it feel right? Because you can pick up on silly mistakes that way in your exams quite easily. I'm going with 11.4. Part B says find the area of triangle ABC. Give your answer correct to 3 significant figures. Okay, so there's an alternative formula for the area of a triangle using trigonometry, isn't there? So area of a triangle is a half AB sine C. And now reformulating that for the triangle that I've been given, the angle I know is A, and the 2 sides I know are B and C, aren't they? So this is going to be half BC sine A that I'm going to be using. Okay, so as long as you've got 2 sides and the included angle, you're good to go really. So that's a half times the 2 sides, 8 and the 11, and the sine of the included angle, so the sine of 72. So what's that then? 0.5 times 8 times 11 times the sine of 72. That comes out to be 41.8 to 3 significant figures. 41.8 centimeters squared to 3 significant figures. Okay. Question 16a. Use the iteration formula xn plus 1 equals the cube root of 10 minus 2 lots of xn to find the values of x1, x2, and x3. Start with x0 equals 2. Okay, so an iteration formula gives you the next term in the sequence if you know the previous one. So this is the symbol for the next term, and this is the symbol for the previous term, isn't it? Now we know our first term is 2, so that's going to be our initial term for xn. Okay, so and we can use x0 to generate x1 using this formula. So x1 is going to be the cube. Is going to be the cube root of 10 minus 2 lots of our value for x0, which is 2. Okay. So right now I'm going to type that into the calculator very carefully and in a particular way. So I can just type one function in once and keep reusing it to find all my other values. Okay. So what I'm going to do first is I'm going to press 2 and then I'm going to press equals. So what that will do is it will make 2 my last calculated value. Now the reason why that's important is because then I'm going to type in the function that I want to find. So shift to find the cube root. Cube root 10 minus 2 lots of the answer. So the last calculated value that I made. Now the last calculated value was a 2, so this is going to sub in the value 2 into that formula and then work out the new one. Okay, so that gives me 1.817120593. Okay, now I'm not going to write down all the digits, I'm just going to write down I think 4, so 1.817. Okay, so I'm just going to round it off to 4 significant figures. x2, now the reason why I did it that way is because now if I just press equals, it will work out the next one for me. Okay, so I didn't have to type it in again because I had the new answer 1.817 as the last calculated value. If I press equals again, it's going to sub that one back in and I'm going to get the next one, 1.853 and change. Okay, and then I'm just going to press equals again and I'm going to get 1.846. and change. Okay. Moving on to part B, the values of x1, x2 and x3 found in part A are estimates of the solution of an equation of the form x cubed plus ax plus b equals 0, where a and b are integers. Find the value of a and the value of b. Now remember, we were given the expression x n plus 1 was equal to the cube root of 10 minus 2xn. Right, now if I want to actually form this into an equation, all I need to do really is replace xn plus 1 with just x and replace xn with just x and then rearrange. Okay, so let's first off try get rid of that cube root on the right by cubing both sides. If I cube both sides, then on the left I'm going to get x cubed. And on the right, the x cubed is going to cancel with the cube root, and that's going to leave me with 10 minus 2x. Okay, and then collecting everything on the left-hand side by adding 2x and subtracting 10, I'm going to get x cubed plus 2x minus 10 is equal to 0. So then comparing that with what I've got up there, then a then is going to be this coefficient of x here, which is 2, and b is going to be this constant on the end, which is negative 10. So a is 2 and b is negative 10. Okay. Question 17. Some people took part in the first round of a competition. A histogram gives information about the scores of these people in the first round. Okay, so you've got frequency density up the left-hand side, and along the bottom we've got a first round score out of 40. Underneath it says 20% of the people who got a score high enough for them to qualify for the second round. Work out an estimate for the score needed to qualify for the second round. You must show your working. Okay, so we need to know. We know that it's 20% of the people who entered are going to qualify for the next round. Okay, so it's going to be people towards the upper end of our data, somewhere up here, isn't it? And we don't know how far we need to go back so that we get 20%. Okay, now so in order to do that, we're going to have to know like how many people altogether took part in the competition. So then we can work out what 20% of it is, and then we can come in that amount of people here, and then we can read off the score here and find out what the score was. So that's the general plan. Okay, so first step, let's find out how many people took part in the competition. Now, in a histogram, the frequency is not the height of the bar. That is the frequency density, isn't it? This is frequency density up here. So the frequency is the area of the bar rather than its height. So what we need to do is to work out the area of each bar. Now, luckily that's not hard because they are rectangles, and rectangles are not very complicated, are they? So if you have a look at this smallest rectangle on the left here, it's got a width of 5 from there to there, and it's got a height of, what's that on that scale? Got 10 little boxes going from 0 to 1, so that's got to be 0.8 then, isn't it? So this bar here then is going to be 0.8 multiplied by 5, width times length, and that is going to give me 0.8 times 5, that's 4, isn't it? Okay, so there are 4 people in that bar there. Okay, now in the next bar along, the width is 10. The height this time is, what was that, 1.6. So this is going to be 1.6 times 10. So this one is equal to 16. In the next bar along, width is still 10. What's the height this time? It's going to be 2.2. 2.2. So 2.2 times 10, that's 22. And finally, the last bar is a height of 1.2. Width this time is, what was that, 15? So 1.2 times 15. So what's that? 12 and 6. That's 18, isn't it? Okay. So total participants is going to be all those numbers added together, isn't it? It's the 4 from the first bar plus the 16 from the second bar plus the 22 from the third bar and the 8 from the fourth bar. the 18th from the fourth bar. So 4 and 16 is 20, 22 and 18 is 40. That makes 60 altogether, doesn't it? Okay, so 60 participants. So then 20% of that then, so 20% of 60, what's that? That's just 0.2 times 60 then, isn't it? Okay, 0.2 times 60, it's going to be 12. So 12 people then scored high enough in the first round to move on to the second round of the competition. So then, where is 12? Now, as we said earlier, it's the people at the top end up here, isn't it? So we want to work out how much we need to cover an area of 12 here. Okay. Now, we know the height of this bar is 1.2. So this is a height of 1.2, isn't it? So then if I want to create an area of 12, I'm going to have to come in 10, aren't I, from the other side, because 10 times 1.2 is 12. Okay, so I'm going to have to divide this bar in half at 10 units in from the highest point. So coming in 10, 5, 10 here. I'm going to divide the bar in here then. Okay, so at that point, this bit here represents 12 people. Okay, so you can see that those 12 people then scored between 30 and 40 marks. So can I work out an estimate of the score needed to qualify the second round? So therefore you needed 30 plus marks. Score required equals 30 plus. Okay, so if you got 30 or higher, then you've done well enough to move on to the next round. Question 18. Here is a graph of y equals sine x for values of x between 0 and 360 degrees. And we can see we've got a complete period of the sine curve there, haven't we? Using the graph, find estimates for all 4 solutions. So 4 is in bold. Usually things in bold are things that students miss. So, you know, if you see something in bold, just take extra special attention to it, because it's something that usually students overlook. Okay? Right, so I want to find estimates for all 4 solutions that sine x is equal to 0.6 for between 0 and 720. Okay, well, 0.6 on my graph is going to be, like you can see, you've got 0 there, 1 there, you've got 10 divisions in between. So 0.6 is going to be 6 little boxes between 0 and 1. Okay, so I'm going to draw a line then at 0.6. Now you can see that cuts my curve in 2 places, not 4. Okay, I've got two places here. Look, 1 there, 1 there. Okay, now I can use my graph to read off what those values are. So coming down from that point, is one solution, and coming down from that point is another. Okay, so what are those values there and there then? Okay, so remember that we've got a scale of 90 here, which is taken up 3 squares, which is 15 little boxes. So how many times does 15 go into 90? It kind of goes in 6 times, doesn't it? 6 times 15 is 90. That means each one of these little boxes is worth 6. So counting up in 6s, 6, 12, 18, 24, 30, 36 then. So the first one is 36 degrees. The next one, kind of counting on from 90. So that's 90. That's going to be 120. So 126, 132, 138, 144. So the second one is at 144. But that's only 2. Okay, so where are the others? Well, if you notice down here, it says between 0 and 720. Now this graph only goes up to 360. So, and sine is is periodic, so it's going to do another oscillation, isn't it? It's going to go up and down again. So we are expecting this graph to go up again and then down again, aren't we? Okay, so there are going to be two additional points where it crosses, like here and here, isn't it? Further along. Okay, so where will those values be? Well, this point up here is exactly 360 degrees further along the line than the one before. So the first one there. So if I add 360 plus 36, I'm going to get what that one is there then. So that one is going to be 360 plus 36. So that comes out to be what? 396. And the other one up here is going to be 360 plus my second value of 144. So 360 plus 144, that comes out to be 465,504. Okay, so they're going to be my two other solutions. So I'm going to have another solution at 396 degrees and another one at 504 degrees. Now I can just double check that on my calculator because I can just type in sine of each one of those and just check it's more or less where it is. So sine 36, that's 0.587, kind of rounds off to 0.6. It's not totally accurate. We're drawing a graph, aren't we? So as long as it's in ballpark, I'm kind of happy. Sine 144, yep, 0.5877, that's pretty close to 0.6. Sine 396. That comes out to be, yeah, 0.5877, same again. And finally, 504, sine 504, again, comes out to be 0.5877. So I'm pretty happy with all those solutions. They're not exactly 0.6, but it's a graph. Hey-ho, it's close enough. Part B says the graph of y equals sine x is reflected in the x-axis. Write down the equation of the reflected graphs. Okay, well, there are 6 different transformations of graphs that you need to know about. And I'll just pull the list up here. Now, reflection in the x-axis happens when you take f of x and you transform it by putting a minus sign in front of your function. Okay, so a negative sign outside the function will have the effect of flipping it in the x-axis. Okay, so what we need to do is take y equals sine x and stick a minus sign in front of it, and that will be our reflection in the x-axis. So y equals negative sine x. That's it. That's all we need to do. Okay, but it's all we need to do because we know this table. Well, I know this table. If you don't know this table, that's something for you to memorize, really. You need to know all of these 6 transformations and their effects. Okay, I tried to summarize it in this table as best I can. Might want to take a screenshot and study it. Okay, moving on. Part C says here is a graph of y equals f of x. That just means y equals f of x means you just haven't defined what it is precisely. But underneath it says on the grid draw the graph of y equals f of x minus 2. Okay. Now pulling back up my summary table of transformations of graphs, you should see down here that y equals f of x minus 2. This is a translation of 2 units to the right, okay, in the direction of x. So f of x minus 2, when you subtract a number from x within the function, that has the effect of moving every point on your graph 2 units to the right. Okay, so coming back to the graph, I'm going to take all the discernible points on my graph. By discernible, I mean like the kind of interesting ones that lie on the grid line easily, and I'm going to move each one of those 2 units to the left. So firstly, this point at negative 4, 1, that's going to move 2 to the right, sorry, to negative 2, 1. The point at negative 2, negative 1 is going to move to 0, negative 1. The one next to it at negative 1, negative 1 is going to move to 1, negative 1. And the point at 2, 1 is going to move across to 4, 1. Okay, so once I've got all my reference points in, then I can just join them up with a ruler. Okay, and then I'll get my new graph, which is a transformation of my old graph. Okay, Question 19. A, B, and C are three spheres. The volume of the sphere A is 125 cubic centimeters. The volume of sphere B is 27 cubic centimeters. The ratio of the radius of sphere B to the radius of sphere C is 1 to 2. Work out the ratio of the surface area of the sphere A to the surface area of sphere C. Now you might be thinking you're going to have to break out like the volume of a sphere and the surface area of a sphere formulas like 4/3 pi r cubed, whatever. But there's no need here. These spheres are just all similar, aren't they? If you've got a sphere, it's going to be similar mathematically to any other sphere. It's a bit like every circle is a kind of enlargement of another circle. They're all exactly the same shape. Okay, so they're all mathematically similar, and therefore their sides, areas, and volumes are all going to be in predictable ratios. Okay, so let's have a think. Let's break this down into ratio of lengths, ratio of volumes, and ratio of areas. So let's do lengths for A, B, and C. Let's do areas for A, B, and C, and let's do volumes for A, B, and C. Okay, so we've got a kind of like a little table going on here, I suppose. We could even make it a table. So then what do we know? We know that the volume of sphere A is 125 cubic centimeters, and the volume of sphere B is 27. So let's write that in our table then. So volume for A is 125, and the volume for B is 27. Okay. Now I know a relationship between the lengths of similar shapes, and their volumes. They're normally like, if you know the ratio of the lengths, then if you square it, you're going to get the ratio of the areas, and if you cube it, you're going to get the ratio of the volumes. Therefore, if I cube root both these numbers, I'm going to get the ratio of their lengths. Okay, so the cube root of 125, I know already, that's 5, because I know my cubes. And I know that the cube root of 27 is 3. So I know that these are going to be in the ratio of 5 to 3 in their lengths. Okay. Now it says that the ratio of the radius of sphere B to the radius of sphere C is 1 to 2. Now radius is a length, so it kind of falls in this category here. Okay. And so we know that the ratio of B to C is 1 to 2. Now I want to formulate that ratio. So if B to C is 1 to 2. Now note down here I've got a 3. So I want to find the number that goes here for C. So it's kind of in step with my other 2. Now I can do that by just taking this ratio and multiplying up by a factor of 3. So that gives me a ratio of B to C of 3 to 6. So this is just the same ratio drawn, using, equivalent values, isn't it? Slightly higher equivalent values. So when for every 3 you've got for B, you've got 6 for C. That means I can now write that 6 at the end here. So the ratio of the lengths from A to B to C is 5 to 3 to 6. Okay. So we're looking good. Work out the ratio of the surface area of A to the surface area of C. Okay. Now, how do I move from lengths, ratios of lengths to ratios of areas? I need to square them. The ratio of areas of similar shape is the square of the ratio of their lengths. So if I square all those numbers, I'm going to get the ratio of their areas, of which surface area is just one type of area, isn't it? So it falls in this areas category again. Okay, so squaring 5, I'm going to get 25. Squaring 3, I'm going to get 9. And squaring 6, I'm going to get 36. Okay, now we wanted to know the ratio of surface area of sphere A to the surface area of sphere C. So they are in the ratio of 25 to 36. So therefore, ratio of surface area of A to C is 25 to 36. Okay, and I did all that without knowing any of the formulas or using any of the formulas for area or volume or whatever, just using facts about ratio of similar shapes. Question 20. In a village, if it rains on one day, the probability that it will rain on the next day is 0.8. If it does not rain on one day, the probability that it will rain on the next day is 0.6. A weather forecaster says there is a 70% chance that if it will rain on the village on Monday. Work out an estimate for the probability that it will rain on the village on Wednesday. You must show all of your work in. Okay, so we're going to have quite a big tree diagram here because we've got three separate events, one after the other, haven't we? We've got rain on Monday or not, and we've got rain on Tuesday or not, and we've got rain on Wednesday or not. So we're going to have kind of three stages to our tree diagram to kind of map this out. Okay, so on Monday first, there is a 70% chance that it will rain on Monday. So presuming that the weather forecaster is right, then on Monday it either rains or it doesn't rain. So rain or rain bar. Bar on the top means not. So it rains or it not rains. Now 70% as a decimal is 0.7, isn't it? So there's a 0.7 chance that it rains, which means there's a 0.3 chance that it doesn't on Monday. So then what happens on Tuesday? Then after that, if it rains or not rains, the probabilities are dependent on what happened on the day before. So if it rains on one day, the probability that it rains on the next day is 0.8. So if it rained on Monday, the probability that it rains on Tuesday is going to be 0.8, isn't it? And the probability then it doesn't rain on Tuesday, not rain, is going to be 0.2. Okay, because 0.8 and 0.2 adds up to 1. Now, if it didn't rain on Monday, then the probability of rain then on Tuesday and not rain. If it does not rain on one day, the probability that it will rain on the next day is 0.6. So that's going to be 0.6 and 0.4 then, isn't it? So that's Tuesday's scenario. And then finally, Wednesday. What's going on Wednesday then? So then on Wednesday, again, you're going to have rain or not rain. Rain or not rain. And you're going to have rain or not rain. You can have rain or not rain. And you're going to have rain or not rain. Okay, and then the probability of that then depends on if it rained or not rained the day before. If it rained the day before, it's 0.8, so 0.8 and 0.2 on that branch, and also on this one here, 0.8 and 0.2. And then on the other branches where it didn't rain the day before, it's going to be 0.6 and 0.4. So 0.6 there, 0.4 there. Didn't write that 0.6 very well. Let's just do that again. 0.6 and 0.4. And 0.6 and 0.4. I don't know if we're going to need all this info. All right, so work out the estimate that the probability that it will rain on the village on Wednesday. Okay, so which roots are rain on Wednesday? Rain on Wednesday is rain, 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 or it's rain, not rain, rain, or could be not rain, 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 or it could be not rain, rain. Okay, so there's four possible outcomes that end up with it raining on Wednesday. So the probability that it rains on Wednesday, that is equal to the probability of rain, 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 plus the probability of rain, not rain, rain, plus the probability of what's that, not rain, 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 plus the probability of not rain, not rain, rain, not rain, not rain, rain. Hopefully that's still on the page. I think it might have wandered off. Let me just budge it over a little bit. Hopefully Hopefully that's back on the page again. Yeah, so then we need to evaluate those 4 things then. Okay, so the green root, which is rain, isn't it? That's the green root there. What's the probability of that? That's 0.7 times 0.8 times 0.8. So 0.7 times 0.8 times 0.8. Yellow root, which is rain, not rain. That is going to be 0.7 times 0.2 times 0.6. So I keep wandering off the edge of the screen. I am aware of this. Let me budget back over again. And then the probability then of the blue route through not rain, that is going to be 0.3 times 0.6 times 0.8. Okay, and then finally the kind of pink route, not rain, that is going to be 0.3 times 0.4 times 0.6. Okay, right, so I think it's time to reach for the calculator, is it not? So 0.7 times 0.8 times 0.8, that comes out to be 0.448. Okay, 0.7 times 0.2 times 0.6, that comes out to be 0.084 plus 0.3 times 0.6 times 0.8, that comes out to be 0.144, and then finally 0.3 times 0.4 times 0.6, that comes out to be 0.072. Okay, so then I need to add all those together then to find the total probability. So what are all those added together? So 0.7072 plus 0.144 plus 0.084 plus 0.448. I make that 0.748. So the probability is 0.748. Okay. So a bit long that one, but we got there in the end, didn't we? Question 21. The time period t seconds of a simple pendulum of length L centimeters is given by the formula t equals 2 pi times the root of L over G. Complicated formula, but it's quite a cool formula as well. It's the reason why if you take a pie, I don't know, what, chicken pie, what's your favorite pie, and suspend it on a string which is of length 1/4 of 9.8 meters and swing it, it's going to take exactly pi seconds to swing from one end to the other and back again. So that's pretty amazing, isn't it? But that's a bit of a by the by, a fun experiment if you get bored. But Katie uses a simple pendulum in this experiment to find an estimate of the value of G. Here are her results. So L equals 52, correct to 3 significant figures. T equals 1.45, correct to 3 significant figures. Work out the upper bound and the lower bound for the value of G. Use pi equals 3.142. You must show all your workings. Okay, so actually this question has nothing at all to do with swinging chicken pies, but everything to do with error intervals, isn't it? It's one of those ones where numbers have been rounded off to a certain degree of accuracy, and you need to then work out what the upper and lower bounds are for the outcome. Okay, so let's have a look at the two values we've been given. L, the length of the string, is 52, correct to 3 significant figures. So first significant figure is the 5, the second is the 2, and the third is the 0 there. So that means this number's been rounded off to 1 decimal place. Okay. Now, in order to visualize that, I like to draw a number line, and I mark on my number line the value that they've been given me, which is 52.0. Then I mark on the scale 1 up from that using whatever rounding they've done. So they've rounded off here to 1 decimal place, or to the nearest tenth. So going up a tenth from there is 52.1, and going down a tenth would be 51.9. Okay, so then the values that are going to round to 52.0 are the ones that are halfway between those values or nearer to 52. So this is the magic range here that rounds to 52.0. Okay, what are the values of that then? What are the bounds of that then? The lower bound then is going to be halfway between 51.9 and 52.0. That is going to be 51.95. And then on the other end, what's halfway between 52.0 and 52.1? That's going to be 52.05. Okay, so that's the upper and lower bound for the length of the string, of the pendulum. Then for t, it's 1.45 correct to 3 significant figures. So again, first, second, third significant figure. This time we're rounding off to the nearest hundredths, aren't we? Okay, so put in again the same sort of thing. I'm going to draw a number line. I'm going to mark on the value that it gave us, which is 1.45. I'm going to go up 1/100th above that and mark that on the scale, 1.46. I'm going to go down 1/100th below that. That's 1.44. And then I'm going to think about what numbers are going to round to 1.45. They're going to be the ones that are halfway between or closer, aren't they, to 1.45. So we're talking about this range of values here. Again, what are the upper and lower bounds of that then? Halfway between 1.44 and 1.45, that is 1.445, okay? And halfway between 1.45 and 1.46 is 1.455, okay? So that's my upper and lower bound for t, which is the time period in seconds, okay? So work out the upper and lower bound for the value of g. Use pi to be 3.142. Okay, so this is a formula given in terms of t right now. We need it in terms of g if we're going to be able to do this thing. Okay, so we're going to have to rearrange it first, aren't we? So it's quite a complicated rearrangement, actually. So let's get cracking with that then. So if t is equal to 2 pi root L over g, okay, then we want to try and get g by itself. But first, I want to try and get rid of that root sign, because I don't want to be flipping things up and down from numerators to denominators while they're rooted. So let's get rid of the root sign first. But before we can get rid of the root sign, we're going to have to move this 2 pi over the equal sign. Okay, cross multiplying that 2 pi, or dividing both sides by 2 pi if you'd rather. I'm going to get t over 2 pi equals the root of L over g. Okay, next step, square both sides. That's going to get rid of that square root, isn't it? Okay, so that's going to give me t squared over 4 pi squared then. Should I do it like that, or should I just leave it? Maybe I'll just leave it as a... No, I'm going to do it like that. 4 pi squared. And that is equal to L over G. Okay. So now what I'm going to do is I'm going to cross multiply. This G is going to go up here. It's going to switch places with the t squared, which is going to go down here. And this 4 pi squared is going to go up there. Okay. So a little bit complicated, but moving it all around, I'm going to get G then is equal to the 4 pi squared is moving up. So it's 4 pi squared. The L stays where it is, divided by the t squared is moving down. So it's going to be 4 pi squared L over t squared. Okay, so that's what G is in terms of the other things there. Now 4 and pi and squared, these are all constants, aren't they? Okay, they're not going to change. I'm going to use that throughout. Okay, but for the L and the t squared, I've got different choices that I could put in for those. I've got my upper bound and my lower bound, and I need to think about which one is going to deliver the highest and the lowest possible values for g. Let's consider the smallest possible value of g first. What's the smallest value of g I could get? Now, the smallest value of g I can get would be if I used the smallest possible value of L, so that's going to be 51.95, and divide it by the largest possible value of t, okay, because that's on the bottom. So if you think about a fraction, the bigger the denominator, the smaller the actual size of the fraction is. So subbing those values in, so that's 4 times 3.142 all squared times L, I'm going to use 51.95, the lower bound, divided by the upper bound of t, which is 1.455. Okay, so what does that come out to be? 4 times 3.142 squared times 51.95 divided by, oh, I should have put a square around that, shouldn't I? Divided by 1.455 squared. Okay? Now that comes out to be 969. Okay? Now I happen to know what gravity is. It should be 9.8 meters per second, and I've got 969. So I had a moment of panic there, but I think probably what's going on is that L, the length of the string, is measured in centimeters rather than meters, and so this is a measurement in centimeters per second rather than in the normal meters per second that gravity is normally measured in. So I think we're good. It's a low measure, but you know, it's our lower bound for g, isn't it? So then upper bound, upper g. What be upper g? Upper g. Now what is the biggest value of this I'm going to get? Well, the first bit has to stay the same. 4 times 3.142 all squared. No changes there. But for the largest value of g then, what I'm going to do is I'm going to pick the largest possible value for L, 52.05, and divide it by the smallest possible value of t. Okay, and that will give me the largest possible value of g, hopefully. So times by biggest L, 52.05, over smallest possible t, 1.445. What does that give me? 4 times 3.142 squared times 52.05 divided by, oh, I forgot the square again. I'm not very good at putting that square in. Divided by 1.445 squared. Okay. Oh, that comes out to be 984. So that's just a little bit above what I believe true gravity to be. So I'm feeling pretty chipper about those. So I've worked out the upper bound and the lower bound value of g. Good. 969 and 984. Okay, no units given here, so I'm not going to put any in. Good. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again next time.